Hey guys, in this video I'm going to show you how to smash those difficult trigonometry questions in a simple and easy way. Now I'm going to start from the very basics and move to the advanced level. So it doesn't really matter if you are opening your textbook for the first time or you've already solved a few questions, you will still find this video helpful. Now before we begin, let me show you what all you can expect from this video. Number one, we'll be starting off with a very general and simple overview. I'm going to walk you through every concept, every formula and every shortcut you need to solve from the very basic to the most advanced level questions. Number two, I'm going to show you how to apply these concepts and formulae by actually solving a few questions for each concept. Number three, finally, we'll be doing some actual past paper questions that have appeared in GCSE exams, and I'm going to show you step-by-step solutions. Now, I have divided the questions in terms of difficulty level into three categories: easy, medium and hard. So feel free to choose whatever your level is accordingly. Let's start with a simple right angle triangle. This triangle has three sides named base, perpendicular and hypotenuse. Depending on where you take the angle, the base and perpendicular are going to switch positions. So for example, here we've taken angle A. The side which is opposite to that angle, which is BC, becomes your perpendicular and the other side becomes base. Now similarly, if you take angle C here, the side which is opposite to angle C, AB, becomes the perpendicular and BC becomes the base. So depending on the angle, the base and perpendicular are going to interchange their positions. Next, we have three important trigonometric ratios when it comes to right angle triangle. The first one is sine. You get sine by dividing P by H, which is basically perpendicular upon hypotenuse. The next one is cos. You get cos by dividing base upon hypotenuse. And the last one is tan. You get tan by dividing the perpendicular with base. So these ratios are very important. Should you memorize them? Yes. And if you want to take a moment to pause the video, feel free to do that. Next, most likely you're going to use these ratios in conjunction with Pythagoras Theorem. So Pythagoras Theorem is a special kind of theorem that is only applicable to right angle triangles. So if you don't know what that is, it basically tells you that the sum of squares of the sides is equal to the square of the hypotenuse. So it looks something like this. As you can see here, AB and BC are sides. Here we've taken AB square plus BC square, and when you add this is equal to hypotenuse square. As you can see, the hypotenuse over here is AC, so we've written this is equal to AC square. So that was about the triangles that are right angle. But what about the ones that are not? For them, we have a different set of rules. One such rule is the sine rule. So we have a triangle ABC on the screen, which is not a right angle triangle. Now let's look at how to name the sides of this triangle, because that's very important for you to understand how the sine rule works. So here, as you can see, the side which is opposite to angle A is named A. The side which is opposite to angle B is simply small b. The side which is opposite to angle C is represented by, again, small c. So this naming convention is very important for you to remember. Now let's look at the sine rule. So this is what it is. Sine A by A equal to sine B by B equal to sine C by C. So as you can see, sine rule gives the relationship between the sine of an angle and its opposite side length. So that's why it's called sine rule. Now let's take an example as to see how we can use this rule in a real problem. So as you can see on the screen, we have a triangle with two angles, 57 and 47, and one side, 8 meters. And you are supposed to find out what is side AB. So this is a really good example where you can use the sine rule to figure out the length of AB. So let's do that. Here we're going to take sine B upon AC equal to sine C upon opposite side AB. Now let's put in the values here. Sine B is 57, AC is 8, sine C is 47 and AB is as it is. Now when you do the calculations, you get AB is equals to 6.38 centimeters. So like that, you can easily find out the length of a side of a triangle which is not a right angle triangle. triangle. Now remember that this sine rule can be used to figure out the angles as well as sides of a triangle that are not right angles. So you can use this rule for a variety of purposes. Now in some situations, sine rule may not be applicable. And when you have a non-right angle triangle, you have another rule which can be applied to figure out the sides and angles of that triangle. That is cosine rule. So as you can see, we have a triangle ABC with sides small a, small b and small c. Now cosine rule is basically a square equal to b square plus c square minus 2bc cos a. So whatever side that you're trying to find out comes on the left hand side, that becomes your a, and or whatever angle that you're trying to find out becomes angle a. So now let's take an example to see how it works. You have a triangle ABC with two sides, AB and BC, and an angle in between. By the way, this angle, since it's given between two sides whose measurement is known, this is called included angle. Whenever you see an included angle, it should strike you that you should use cosine rule. So let's use the rule here. We get AC square. Since we're trying to find out what AC is, we put it on the left hand side. AC square equal to 7 square plus 5 square minus 2 into 7 into 5 into the angle opposite to AC, or the included angle, which is 60 degrees. Now when you do the calculations, you get AC equal to 6.24 centimeters. So this is how you apply the cosine rule. Now remember that it can be applied in two situations. One, when two sides and included angle is given in the question, you can apply this rule. Two, if all the three sides are given in the question, you can also apply this rule. Now let's talk about the area of a triangle. So to figure out the area of a triangle, the most basic formula is half into base into height. Now in certain situations, you might not be given the height of a triangle, or you might be given the sides and the angles of a triangle. So in that case, we use an alternative formula to find the area of a triangle, and that is half AB sine C. So here all you're doing is taking two sides of a triangle and multiplying it with half of the side of the angle between them. So what I'm trying to say is, let's say you're given side C and side A, and the including angle is B. So to figure out the area of such a triangle, you're going to multiply half into A into C into sine B. Similarly, let's say you're given side B and side A, and the including angle, which is the angle between these two sides, is C. So to figure out the area of a triangle, you're going to use the formula half AB sine C. So here we are given a right angle triangle where you have one angle, the measure of one side, and you're supposed to find out the other side. Now before we start doing the calculations, let's just try to see what we have and what we are trying to find out. So here the angle given here is 61 degrees. As we know, the side which is opposite to the angle is called perpendicular. So this right over here is my perpendicular. If this is the perpendicular, obviously the other side becomes the base, and this one, the side which is opposite to this 90 degrees, becomes the hypotenuse. So as you can see, we have the hypotenuse, we need to figure out the perpendicular, we also have an angle. The best trigonometric ratio that you can use is sine over here, which is given by perpendicular upon hypotenuse. So I'm going to take sine 61 here, that is equal to perpendicular, which is b, upon hypotenuse, which is 4. So b is equals to 4 times sine 61, that is equal to 3.5 centimeters. So that's the measure of side b. So here we have another right angle triangle. Two sides are given whose measure is 4 and 6 centimeters respectively, and we are supposed to find the angle T over here. So let's just try to write down what we have first. So if this is the angle that we're considering, the side which is opposite to this angle is perpendicular. So basically this is the perpendicular. The other leg of the right angle triangle becomes the base, and the side which is opposite to 90 degrees is the hypotenuse. So as you can see, we have the hypotenuse, we have the base, we need to figure out the angle. So the best trigonometric ratio in this situation is cos. So cos t is equal to base upon hypotenuse. So I'm just going to put in the values now. Cos t is equals to base is 4 upon 6. So t is equals to cos inverse of 4 upon 6, and when you do this calculation you get t equal to 48.2 degrees. Alright, so here we have a bunch of triangles and we are supposed to find what angle x is. So before we start solving the question, let me just name the angles of this figure. So this is A, let this be B, this is C, D, and let this point be O. So now to figure out angle x, we have to consider triangle ABC. And in this triangle ABC, we already have one side whose measure is 10 units, but we do not have any other side apart from that. And to figure out x, we need at least one more side. So I'm going to figure out what AB is so that I can use a trigonometric ratio to find out x. Now, if you observe, AB is AO plus OB. It is the length of AO added to the length of OB. So what I can do over here is I can figure out the length of AO using this triangle and figure out the length of OB using this triangle, add them up together and figure out what AB is. So let's do that. Let's talk about AO. In triangle AOD, we have one angle 58.2 degrees and we have one side which is opposite to it, so basically it's the perpendicular, and we are supposed to find out AO, which is the base. So in this case I'm going to use tan. So tan 58.2 degrees is equals to 12 upon AO, or perpendicular upon base. So AO is equals to 12 divided by tan 58.2, and when you do this calculation you get AO to be 7.44 centimeters. So that's the measure of AO. Now let's look at the other part, OB. So to figure out what OB is, I'm going to consider triangle BOD. So here, as you can see, you have angle 28 degrees and you have a side which is touching this angle, so this becomes the base, and you're supposed to find out this side which is the perpendicular. So again, a good ratio to use here is a tan. So I'm going to take tan 28 degrees is equals to perpendicular upon base. So here my perpendicular is OB upon base is 12. So OB is equals to 12 times tan 28. So that gives OB to be 6.38 centimeters. So now that you have OB and AO, you just need to add them together to get AB. So when you do that, you get AB to be 13.82 centimeters. Now in triangle ABC, I have the perpendicular, I have the hypotenuse. So let me just redraw ABC so that it's easier for you to understand. So as you can see here, we have the perpendicular and we have the hypotenuse. So we can use the ratio sine to figure out what angle x is. So sine x equal to P by H, x equal to sine inverse of perpendicular, which is 13.82 upon 10, and when you do this calculation you get x to be 46.3 degrees. From a lighthouse L, an aircraft carrier A is 15 kilometers away on a bearing of 112 degrees, and a submarine S is 26 kilometers away on a bearing of 200 degrees. So this is the diagram. Here you need to draw the diagram by yourself by the given information. So let's do that here. So let's start with the lighthouse L. Let this point be L over here. Now it says that an aircraft carrier A is 15 kilometers away on a bearing of 112 degrees. So they've given you the angle and they gave you the distance as well. So here let's say that this is the perpendicular, this is the north. So this is point L, this is the north direction. From here we're going to consider 112 degrees clockwise. Remember guys, it is clockwise, bearings are always clockwise, so do not get confused. So from here I'm going to take 112 degrees. Let's say that it's approximately somewhere over here. So now at a distance of 15 kilometers, this is where we have A, aircraft carrier, and this is 112 degrees. So now we're done with that. Next we have a submarine which is 26 kilometers away on a bearing of 200. So this time let's consider a bearing of 200 degrees. Again, here we're considering the bearing from point L. So from here let's measure 200 degrees, so approximately it will come up to this point. So let me just draw a line which is of 26 kilometers, which has a scale 26 kilometers, and let's just call this S as given in the question, and this entire angle is 200 degrees. Now let's join A and S. So this way you have a triangle LSA. Now the first thing is you're asked to find the distance between A and S. So before we find the distance between A and S, let's try to figure out the angles, because if we are supposed to use sine rule or cosine rule, we need one or the other angle. So here let's try to figure out the angles. This part is as it's given in the question. This is 112 degrees. If I draw a horizontal line here like this 112 degrees gets divided into two parts. This part is 90 degrees and this part is 22 degrees. So 112 degrees gets divided into 90 degrees and 22 degrees if I draw a horizontal line. Now let's try to use the same logic for the bearing of 200 degrees. So we know that submarine is at a bearing of 200 degrees, right? So that means this entire angle is going to be 200. But we know that this part is 112 degrees. So this part is just 200 minus 112. So that is 88. So this is 88 degrees. And this is 22 degrees and this is 90 degrees. So now we have angles ready. So the first question is distance between AS. So we are supposed to find side AS here. To do that, I am going to use cosine rule. The reason I'm using cosine rule is because, as you can see in triangle LSA, you have two sides whose dimensions are given, and you have an including angle. So this is where you use a cosine rule. So that would be a square equal to b square plus c square minus 2bc cos a. This is cosine rule. So let me just put in the values. As square is equals to ls square plus la square minus 2 times ls la cos of angle between them, which is L. Right, now just put in the values. You get AS square is equals to 26 square plus 15 square minus 2 times 26 into 15 into cos 88 degrees. And when you do the calculation, you get AS to be 29.56 centimeters. So this side over here, that is 29.56 centimeters. So to again have a quick recap, what we've done here is, first we found out one angle over here. We found out angle L, and then we used cosine rule to figure out the side AS. The next part of the question is find the bearing of A from S. So let's just try to see what the bearing looks like here first of all. So here the bearing of A from S is basically, if you draw a perpendicular at S, this angle is what they are asking you to find out. Now as you can see, this angle is this angle plus this angle. So the bearing can be divided into two parts. So we can find these two angles over here and then add them together to get the bearing. So let's do that here. First let's try to find this part. So this can be found out by using sine rule. I'm going to use sine rule here for the same triangle. This is, so that would be sine S upon the opposite side. The opposite side is what? LA, right? And then that is equal to sine L upon the opposite side. What's the opposite side of L? AS. So that would be sine S upon 15 is equals to sine 88 degrees upon 29.56, and when you do the calculations you get sine S to be 30.47 degrees. Now here 30.47 is just this part. But what about this angle? Because you need that as well to figure out the bearing, right? So for this, we are going to draw a triangle. Let me take a different colored pen. Yes. So let's consider this triangle. Let's draw a perpendicular from S like this. And let's now consider this triangle. So this is, let's say, D. So in triangle DLS. In triangle DLS, angle D is obviously 90 degrees because it's perpendicular to the horizontal, and then angle L here, this angle is easy to figure out. You just need to use linear pair. So here 88 plus 22 plus this angle over here, that will sum up to 180 degrees. So use that logic, you get this angle to be 70. So if in a triangle one angle is 90, the other angle is 70, so to figure out the last angle you just need to subtract that from 180. When you do that, you get 20 degrees. So now we know that this angle is 20 degrees and this angle is 30.47 degrees, and when you add them up you get 50.47 degrees, which is the bearing of A from S. Let me introduce you to Edify Right, a website that has video solutions for topical past papers from IGCSE Math. Here you can search for different IGCSE Math topics, pick the year and watch the detailed video solutions. You can even download the marking scheme. All of this is completely free. There also is a feature for group discussion, so if you have any doubts, there is always a group of dedicated educators that will help you out with your doubts and questions. And if you're wondering how to access this website, the link is in the description and you can access it for free. Alright, here we have the diagram shows the triangle ABC. X is a point on BC, as you can see, and all the different measures AX, XC, angle B and angle X are given. Now the first part of the question is calculate AC. So let's do that here. So this is AC, this is what we're supposed to find out. So let's take a part of this triangle. Let's take a smaller triangle AXC to figure out what AC is. Here in this triangle, if you see, we have two sides over here, and also we have the angle between these two sides, which is this. Now it's not directly given in the question, it's just that 78 degrees and this angle are supplementary because they lie on a straight line. So if you add them up, you get 180 degrees. So in that sense, this is basically going to be 102 degrees. So yes, now that we have the angle, also let's use cosine rule to figure out what AC is. Let me just write the formula first. AC square is equals to AX square plus XC square minus 2 times of AX CX or XC into cos of angle between them, which is angle AXC. So here AC is unknown, so let's keep it as it is. AX is 10.6, XC is 6.4 minus 2 times 10.6 into 6.4 into cos of the angle between them, which is 102 degrees. So when you solve this, you get AC is equals to 13.5 centimeters. So that's the first part. Next we have calculate BX. Alright, let's do that here. So this is BX and you're supposed to calculate the length of BX. So this time let's use sine rule. I'll show you why. So this is the triangle we're talking about, triangle ABX over here. Now here we have one side and its opposite angle, and then we have another angle. This is again directly not given in the question, but it's obvious. How can you find this angle? Just by subtracting 58 and 78 from it. So you get 44 degrees as the measure of this angle. So let's try to use sine rule here. We have AX by sine 58 degrees is equals to BX by sine of opposite angle, which is 44 degrees. And AX is obviously 10.6 here, so let's put in the values. Is equals to BX, that's what we're trying to find out, by sine 44 degrees. And when you do the calculations, you get bx is equals to 8.68 centimeters. So that's how you find the length of bx, by using sine rule. Most of the trigonometry sums you either have to use sine rule or cosine rule basically. Next we have calculate the area of triangle ABC. So this is pretty simple. You have this triangle ABC and you're supposed to calculate its area. So obviously we can't use the basic formula, which is half base into height, because we do not have the height. So we have to use the trigonometric way of finding the area of this triangle, which is half AB sine C, or you can say half into side into side into the angle between the sides. Now let's talk about ABC. Here we can figure out the area of triangle ABC is half into this side multiplied by this side and the angle between these two sides. So I can just write it as AC into BC into sine C. The issue here is we do not know what is sine C. We have the measure of AC, we found out in the first part of the question. We have the measure of BC again, but we do not have the measure of this angle. So let's try to figure that out first. Let me just clear this off. Yes. So to find angle C, we're going to use the sine rule yet again. So this is sine C. I'm talking about this triangle. So I'm taking a part of the triangle. I'll just write it here. In triangle AXC, I'm using the sine rule, where sine C divided by the opposite side, which is 10.6, is equals to sine 102. This is 102, right? So sine 102 degrees divided by the opposite side over here is AC, which we've already found out to be 13.5. So let me just write it here. Now when you do the calculations, you get C as 50.17 degrees. So now that we have C, we can use this formula to figure out the area of triangle ABC. So this is half into AC is 13.5. BC is this part plus this part. So that would be 6.4 plus 8.68 into sine of the angle between them, basically sine C. This is 50.17 degrees, right? So that is 50.17 degrees. And when you solve this, you get area to be 78.17 centimeter square. This is the answer. The diagram shows a quadrilateral ABCD made from two triangles ABD and BCD, and the first question is, show that BD is equals to 16.9 meter correct to 1 decimal place. So we are supposed to find the measure of this side over here. So for this, let's consider triangle ABE, and we're going to use the cosine rule. Why the cosine rule? Because we already have two sides in this triangle and the angle between these two sides. So we can use the cosine rule to figure out what is BD over here. So let me just write the equation here. BD square is equals to AB square plus AD square minus 2 times of AB, AD, and the cosine of the angle between them, which is angle E. Now just put in the values, you get BD square is equals to 16 square plus 19 square minus 2 times 16 into 19 into cos 57 degrees. And when you simplify this, you get BD is equals to 16.91, which is exactly what's asked in the question. Next we have calculate the angle CBD. So let me just mark angle CBD over here and clear all this. Okay, so this is angle CBD. We're supposed to find this out. Now to find this angle, we have to consider triangle CBD. And this is 16.9. Let me just write it here. Now in CBD, we have two sides and two angles. So we can use the sine rule here to figure out what this angle is. I know that we're supposed to find this angle, But first we have to find angle C in order to do that. Why? Because in sine rule we take angle and the exact side opposite to it. So if you take sine B directly here, if you take this angle here, this is the opposite side whose measure is not available, so we can't be doing that. So that is why we have to first figure out what this angle is. So let's do that by using sine rule. So I'm going to take sine C divided by the angle, the side opposite to sine C is 16.9 is equals to sine of angle CDB. So this is angle CDB. Why are we taking this angle? Because we have the side opposite to this angle as 32. So that is the reason, divided by BC. Now put in the values. Sine C upon 16.9 is equals to sine 75 upon 32. So when you solve this, you get C is equals to 30.7 degrees. So this is 30.7 degrees. Now in this triangle BDC or CBD, you have two angles. So you can easily figure out the third angle by just subtracting it from 180. So this angle is basically going to be 180 minus 75 plus 30.7, which is equal to 74.3. So this is the measure of angle CBD. This angle is 74.3. Next we have find the area of quadrilateral ABCD. Alright, let's do that here. So to find the measure of quadrilateral ABCD, you just have to take the area of this triangle and the area of this triangle and add them up together. So that is basically triangle ABD plus area of triangle BCD. Let's do that. So area of triangle ABD is given by half into 16 into 19 into sine 57. So if you're wondering, I'm basically using the formula half AB sine C to figure out the area of triangle ABD. And for BCD also, we're going to use similar formula, which is half into 32. We're going to consider this side and the angle between these two. So that would be half into 32 into 16.9, and the angle between them is sine of 74.3. We just found angle CBD in the previous part of the question, so that is 74.3. Now when you calculate this, you get 387.7 centimeters square. So that's the area of this entire quadrilateral, which I got by adding the area of individual triangles. Next we have find the shortest distance from B to AD. So whenever we say shortest distance, it's basically the perpendicular, guys. So they are asking you to find out from B the shortest distance, the perpendicular from B to AD. So to solve that, let me just clear this out first. Here we're going to equate the area of triangle. So when we say the area of triangle ABD, it can be found out in multiple ways. One way is just to use the usual formula, half into base into height. So in triangle ABD, half into base is going to be 19, height we don't know, so we'll just take it as it is. H is equals to, another way of finding the area of this triangle is again half AB sine C, right? So we're going to use that, half into 16 into 19 into sine 57. So H is equals to half and half get cancelled, 19 and 19 gets cancelled, 16 into sine 57 degrees, and when you simplify this, you get H equal to 13.4 meters. So basically that is the shortest distance from B to AD.